Hello, everyone. This is Francesca Vigliani from Cloud Academy. Thank you for joining us for this data science webinar. This time we're focusing on data visualization and we're very excited about it. It's so great to see so many of you participating in this session. I'm seeing some names from people that already attended our Pandas Like a Boss series. So welcome back to whoever already knows our Andrea Giussani, and welcome to all new attendees. Before we get started and before introducing our speaker, just a few housekeeping announcements. You already know the drill by now. I'd like to remind you that this webinar is being recorded and will be shared with you via email. During the webinar, we will leave time for your questions, so feel free to add them in the chat box and our expert will try to answer them during the final Q&A. Lastly, we hope you had time to set up the environment so that we can get going with the session. If you have problems, don't worry. You just need to have the data on your Google Drive. You should have received the GitHub repo, so please use it. I will send it through the chat so that you have access to it. And I think that's about it from me. I'm done with all the announcements. So without further ado, let me introduce you to our data scientist, Andrea Giussani.
Thank you, Francesca, and welcome everybody. Nice to see so many people today, and thank you for participating in this data science event. I'm really excited about it. So, as usual, just a brief introduction of myself. I'm a data scientist here at Cloud Academy, where I mainly focus on the development of machine learning algorithms to provide state-of-the-art solutions to improve the quality of our product. You can reach me out on LinkedIn, or you can visit my website for updates on machine learning or Python in general. All the details can be found in the webinar-specific GitHub repository, and the URL is provided in the registration email as well. Please note that I will upload the full transcript of this live demo as soon as we finish the session. So if you don't get everything, don't worry, because everything will be shared with you at the end. So the agenda goes as follows. We're going to look at the environment and the data, because I believe it's the crucial part before we get started. And then we will try to understand what we are going to understand today and what we are going to tackle the problem using the methods that we are going to learn today. So as I said, it's important that you get a working environment before the start of the webinar. I have provided all the instructions in order you to be able to set up a Google Colab environment if you don't know it. And there is a quite well-written README on the GitHub repository. I believe that you should be able to set up it independently. In particular, we're going to use, as I said, a Google Colab environment for many reasons. In this way, you don't need to care about your working environment system in the localhost, and we can easily perform a demo session without caring about the Python that you have installed in your local environment. So having said that, I have also uploaded on the GitHub repository a template that should help you in attending this live session. And if you think about data visualization in just a part of a pipeline, which involves sometimes data manipulation and transformation, and therefore in this way you should only care about the data visualization part, and all the transformation has been already provided in the template. So again, that template is available in the GitHub repo, and be sure that you have it in your Colab session. But it's not necessary. Obviously, we're gonna look through all the details together. Last but not least, the data. So today I've chosen a quite popular data set that takes into account the FIFA dataset. FIFA is a very popular video games for PS5 and for Xbox, and but even for PC. and FIFA is basically a football video game. And in particular, we are going to focus on two main quantities: the overall evolution of the players. The overall is basically the overall skill, and the wage evolution by some countries. So those are the two main objectives of today. So without further delay, let's jump into what we believe is important to learn. So this is basically a webinar on data visualization. Just to give you an idea, in Cloud Academy, we have a few content on data visualization, either specifically on the cloud, either on AWS, on Azure, but even with Python. So if you're curious, you can search in our content library to search for advanced courses on this fascinating topic. Today's webinar is we're going to just cover a brief introduction to data visualization, and in particular, we need some skills. Basically, Python. We need to know at least Python programming, but in particular, we must know how to deal with data frames, and this is basically what we cover with our Pandas Like a Boss series. So if you haven't followed it, or if you don't know Pandas, don't worry, because we have tons of materials in our content library. So check it out if you're curious and if you want to learn more on those topics. So today we are going to understand why you should care about data visualization. And as I said, it is a very important topic, sometimes undervalued in the data science, but I believe it is a key feature if you want to distinguish yourself in the market. And the natural question is, why is that? If you think about any output is expressed in terms of data, and they can be tabular data, obviously, and in this way I mean that sometimes the output is shared with your colleagues via an ETL, or better with your stakeholders, right? So either they are stakeholders or colleagues, you share some data, okay, as an output. But as a data scientist, you have to give a soul to those data, to that output, basically. And typically, this is done via data visualization. So data visualization is nothing more than a tool that allows you to transform some data from a tabular shape to a graphical dimension. And in particular, we're going to look at a very particular library, a Python library that allows you to perform data visualization with open source, basically libraries. So, and this is called Bokeh. Bokeh was born in 2015, and it is a very nice and popular data visualization library for many reasons. I believe the most important one is that it allows you to give you dynamic dynamicity, interpretability, and in particular, it gives you also the possibility to give flexibility inside the plot. And we will understand how this is implemented in Bokeh. As I said, at first, Bokeh is very nice because it gives you dynamic visualization, and we will see that this dynamic visualization is typically done using inspectors in Bokeh, and we will understand what is an inspector today. So last but not least, the recording will be available even offline, and it is publicly available on our YouTube channel. So check it out if you want to watch back this webinar. So when I was trying to think and basically create this webinar, I was thinking of three main areas that I want you to take home at the end. And the first is how to create a plot in Bokeh. And this is done typically using the submodule called plotting. And we will see how to exploit that submodule to produce good looking plots. The second point that I want to mention today is how to bring interactivity inside the plot, as I said before. And this interactivity is usually done using glyphs. But the glyphs require some tools that are specific to Bokeh called inspectors. And the most important inspector is the Hoover tool. So we're going to look at those three main topics today. And at the end of this webinar, you should be able at least to understand how Bokeh works, and in particular, how it differentiates between other very common Python libraries for data visualization, thanks to this dynamic visualization that is typically used inside the Hoover tool. Okay, so without further delay, let's jump into our notebook. And in particular, as I said, we're going to look at Bokeh in its very general terms. We are going to exploit a popular dataset that contains basically the time series evolution of the football players in the FIFA video games. As usual, we are gonna, so the data are stored in my drive, and I guess you should have same environment as mine if you have followed the README. So let's mount our drive inside the collab using the drive method from the Google Colab library. And we actually need to authenticate. You should do by yourself as well. Okay. So once you have authenticated, this is necessary step, obviously. We have to import Pandas in order to read the data. And the data are stored into a compressed file, a zip file, and in particular, the read CSV method, which is a very popular method to ingest data with Pandas, allows you to ingest directly the zip by just passing the string that contains the path to that file. Okay, very simple, as usual, with this very nice function from Pandas. And once we load the data, you can expect the first two rows, and the data are structured like this. You have 107 columns, and here you have the first two players, Messi and Cristiano Ronaldo, very popular. And in particular, since here we have a time series for each single player, namely we have a longitudinal data for each single player, multiple repetition for the same player. This is the definition of longitudinal data. In order to check that this is true, you have here the column called year that tells you in which year was observed the player. And in our case, we had 2015, but you can obviously get more information using the describe method, for instance. And the describe is gonna tell you that the year goes from 2015 to 2021, okay? So we have a multiple observation for the same players repeated in those 6 years. It's a nice data set. In order to get some insights, as I said at the beginning of this webinar, we are going to look at two main objectives. The first one, we want to understand how to translate tabular data that describes the evolution of a player in a graphical dimension. And secondly, we want to check the evolution of the wages clustered by year and by nation of the players. So those are the two main questions that we want to try to answer in this webinar. Pretty simple, but at least they give you an idea on how to tackle such kind of problems using Python, in particular using Bokeh. So to facilitate our life, and in particular to make all the process more smoother, I have selected just a few columns from the dataset. And if you think about here, I'm just using classical filtering or better slicing using Pandas, since I have a data frame, and I pass explicitly the columns that I wish to keep in this object called filter data frame. And in particular, we're going to take the name, the age, the nationality, the club in which he's playing, and his overall, and the wage. Okay, so let's run this cell. And now comes the meat of today. So we got the data. The data looks like this. Obviously, you have already seen them, but just to give you an idea, looks like this, okay? And to be sure that, for instance, we are getting all the data for our players, let's try to filter, let me say like this, we're gonna take a Boolean condition based on the data frame. And in particular, I'm gonna look at the short name. And for instance, I want to be sure that in my data frame, there are all the 6 observations for a player. Let me take Messi, it's the easiest. And so in this way, what we should get is a data frame that is filtered with respect to the name, here Messi. And we got exactly 2, 4, 6, 7, sorry. It's a 7 because it's 2021. So pretty simple, right? So we got all the data. At least this data set is readable from a human being perspective. So now let's try to translate those tabular data into a graphical dimension. As I said, one possibility is to use the Bokeh library, in particular the plotting submodule. And in the plotting submodule, it's quite a nice submodule since it contains several methods, such as the figure one. And the figure allows you to basically plot and customize a figure and a plot, obviously, inside Bokeh. Bokeh is based on Matplotlib, so everything that you know about basic plotting in Python is still present in Bokeh, but Bokeh has a different terminology with respect to Matplotlib, in particular with respect to the object that you draw on the canvas. And in particular, when you draw something on the canvas, in Bokeh typically this operation is called glyphs. So Bokeh works with those kind of objects called glyphs that are nothing more than lines, circle, or whatever you can think of when you want to translate some categorical data into a graphical dimension, like, such as a histogram or a bar chart. Okay, so everything that is drawn inside the canvas is called a glyph in Bokeh. So the Bokeh plotting submodule contains the figure object that is used to create a plot, and then we customize that plot using glyphs that are specific to the method figure. So let's try to get our hands dirty and let's try to basically create a simple plot. And we want to plot let me say, the evolution of Lionel Messi from 2015 to 2021 with respect to the column overall. And to do that, we are going to import the Bokeh submodule called plotting. And we import, obviously, the figure, since, as I said, it's important that it's the fundamental block to create a plot. And then I import also 2 important functions, that is the show, which is used to show the method, the plot, sorry, and the output notebook, which is a very specific function that is called when you are working with Jupyter Notebook, like the one that we are using here in the collab. Otherwise, if you are using a standard Python script, you should import the output function, the output file, and that's it. So the output file has also different use because it is used to store something locally. So you got a plot and you store it, but the output notebook allows you to dynamically see what you have produced inside the cell in which you are running that particular block of code. Okay, so once we import those, we, as I said, we call basically the output notebook. This is necessary since we have to tell Python to show the plot as soon as we create it, and then with just two simple line of codes that I'm gonna write now, we are able to create a plot for a specific time series. In our case, the messy time series. So how can I do that? So we're gonna create a variable called plot, and I store inside this variable the figure object, which has many arguments. The most important one are the plot width, obviously, and I store this as and save it as a 400 inches, and the plot height. Again, we store this as 400 for simplicity. Those are the main one, but we're gonna look at some of them in this webinar. Otherwise, there is full content in our content library related to such kind of arguments. Please check the course on Bokeh if you're curious. And then we basically apply the method on the plot, and those methods that I was mentioning before are called glyphs. Glyphs are nothing more than basically the object that you draw on the canvas, on the actual plot that you want to show. So, for instance, Bokeh has many glyphs, from line to circle to any other methods that can be used to produce some plots. For the moment, let's focus on the line one. That the glyph line is gonna translate some data into a line in the canvas of our plot, and the line requires basically 3 arguments. At first, the x dimension, and typically the x dimension is, in our case, we want to see how the overall score for messy evolved over time. So on the x-axis, we're gonna put the year as a string, as simple as that. And then we pass the y, which is the overall score. Remember here is this column. And then obviously we have to tell Bokeh where to get those data, and those data can be taken from a source data frame, which is nothing more than, for instance, let me say like this, is gonna be filter df, and we query. Query is a popular method to slice a data frame, and we query it using the short name column equal to lion messy. Sorry for that. Okay. So in this way, you are just taking into account all the observation for lion messy for each single year. And then we also specify the color equal to, I don't know, red, just to give a color to the line. And finally, we show the plot by calling the show function that we imported before, and as simple as that. So in 3 lines, we are able to plot some data with Bokeh. So let's try to run it. Okay, there is something that is well, it's okay. So it's for messy, possibly it's not very interesting since it's the top player in FIFA. So let me do, I don't know, Jeremy Vardy, which was not so popular at the beginning in 2015 and 16, so possibly it had a different increase. Yes, it is. So for a different player like Jeremy Vardy, which is a Leicester player, this is the overall evolution for that particular player from 2015 to 2021. So apart from the data, the nice thing, so the question is, why are you keen on Bokeh? For many reasons. At first, because with this simple plot, you have a few tools here on the right called gesture. And gesture are static tools that allows you to interact with the plot. For instance, you have the pen, which allows you to move in the plot, okay? Or with the zoom allows you to draw a particular box inside the plot and focus on some particular cases. There we go. And there are many, many others. Or I'm not gonna look at them for each single. Just a few seconds. I have to charge my laptop. Here we go. There are a few of them, and one is the save. The save allows you to directly store the output that you see here in your local host without the need of caring about the output file method. Okay, so there are few things that actually are pretty nice because it gives you interactivity inside the plot. And so another interesting fact is that it allows you to customize it. So for instance, let's try to add some legend. So to add a legend, you can use the legend label. Legend label, yes. And for instance, I'm gonna use the name of the player, Vardy, and in order to show that particular legend, you have to access to the location attribute of the legend in this way. So you call the legend and you call the location attribute and you specify where you want that name to be shown. So since we have space here in the bottom right, we're going to specify the bottom right location. And we get, something that describes at least the series with respect to the player. You can also add a title here, evolution, just to give a title. But I mean, it's just a way to give some specific customization to that plot. And as you see, it's easy. It's more easier than Matplotlib when it comes to customization, although it is based on Matplotlib. But at the end user, like me now, it's not so involved in the customization part. The Bokeh is pretty direct and pretty easy. So this is okay. So we have already added the legend. Another interesting aspect is, okay, we have seen a single line, so we plot a single time series. How can I plot multiple time series? Well, it's pretty easy, okay? It's the same argument that we just used, but with multiple time series. So for instance, I'm gonna take the Vardy data frame that I just mentioned, and we are gonna look at other three. For instance, I'm gonna look at, I don't know, Lukaku, which is international Milan football player from Belgium. Lukaku is Romelu. And then you get the, I don't know, Immobile, which is an Italian striker. And it's called Ciro Immobile. So we are going to filter the original data frame with respect to those three strikers, because all of them are strikers. And then we basically want to plot all those data in just one single plot. When it comes to when we want to do this, basically we need to first specify a glyph for each single player. Second, each single player is described by a specific legend label. And third, each single player is specified by a color, right? So to do so, for colors, I'm going to use the palette from Bokeh, and in particular, I'm going to use the colorblind tree, namely it returns 3 distinct colors in just with an iterable, so we can easily deal with that in I don't know, in a for loop, as we're going to do now, and then we proceed as usual. So we create a figure that I call here P. And then here is the most tricky part, because we have to loop basically over those 3 datasets in order to create for each single dataset a line in our plot. So let me do like this. For I'm gonna call the data. So for data, which is the data object, the data frame that we wish to plot, the name, which is the label, the legend name, and the color, and we are gonna zip all those. We are gonna extract those 3 elements from basically 3 sources. The data frames. So we got the var DDF. Don't worry if you don't get everything about this part. I could have written in the student template, but it's fine. We're gonna do this together. It takes a few seconds. So Vardi, Lukaku, and Immobile, we said. So we're gonna take data from that list of data frames. We get the names from a list of strings that we assign now. So Vardi, Lukaku, and then we got Immobile, right? And then we use the colors that comes from the colorblind tree that we just imported. And in this way, we are able to loop over those 3 elements. And we are going to create, for instance, a data frame using the Pandas data frame function, and we call the data, although it's still is already a data frame, so it's not really necessary. But in case you don't have a data frame, you have to translate that in a data frame. And then you plot basically a line for each single data set. In particular, we are going to do this df in position here. Let me do like this, like before. So x equal to here. Then we have the y, which is the overall. And then we get the color, and we use the color that we are looping here in this for loop. And then we assign the legend label as the name that we have here. Okay, and then we finally, once we have completed this, we can show the plot. But also, we add a legend as we did before. So we access to the attribute, the location of the legend, and we specified bottom right as before. Okay, so that was the trickiest part. It's just a for loop, but we iterate over 3 distinct objects: data, name, and color. So why is that? Here is not necessary, sorry. Ah, yes, sorry. I missed the source. I'm sorry for that. Right? Because he doesn't know what ER and overall means without a source. Here we go. So here we got the evolution of those players with distinct colors. And again, it's the same structure, but it's a way to visualize some series. Again, you have here the gestures that, and then you can, for instance, zoom into some specific area of the plot easily, and you can reset it by just using the gesture call reset. As easy as that, okay? And this is nice because we get at least a simple interactivity with the plot for free. But the nice thing about Bokeh is not just that it allows you to have this gesture, it allows to give you a sort of dynamic visualization inside the plot, as well as flexibility. And for instance, we can add some interactivity in the plot, in particular with respect to the legend. What does it mean? It means that, as I'm saying here, in this simple text box, you can actually mute a certain glyph directly using Bokeh. Muting means that suppose that you have not 3 but 10 different players in the same plot. Sometimes it can be a little bit messy to look at it, and you want to actually compare some player stats, but you don't want to show the same stats for all the players in the same graph. And to do that, you can mute or hide some specific glyph related to some players using the click policy property on a legend. So it's pretty easy, you will see now. And this is beautiful because in just one line of code, you can replicate what you have written here, and that I'm gonna copy and paste, as simple as that. But I want to mute, I want to be able to mute some glyphs in the plot. And to do that, we are basically gonna we're gonna specify, sorry, the attribute click policy on the legend, and you specify either hide or mute. It's the same. And in this way, you get exactly the same plot as before, right? Nothing has changed. But look at now, look at now at the legend. You have some interactivity on that. And as I said, you can mute some players by just clicking on it. Look at the yellow line, it disappeared. Look at the Vardy one, it is disappearing. So in this way, you have in the background, so in the backend, you have all those players, but then it's up to you to choose which one to turn on or off, depending on your needs. And so this is a very interesting aspect on data visualization with Bokeh, because it allows you to create a sort of dynamic visualization and engagement with your stakeholders and colleagues, because it allows you to interact with the plot, which is a very nice property, in my honest opinion. And for instance, with standard Python libraries such as Matplotlib, Pandas, Seaborn, you can't do that. So Bokeh allows you to create this dynamic interactivity. And so if you want to, for instance, in your daily job, share some data and you want to create some engagement with that, with the plot that has been generated with those data, possibly this interactivity, it's a nice feature to share. So again, lovely feature with just one single line of code, which is the click policy attribute on the legend. As simple as that. Okay, so We're moving now to another important topic. So we have understood how to create a plot on Bokeh. We understood why Bokeh is important, because it allows you to give flexibility and interactivity inside the plot. One possibility to interact with a plot is with the legend, but the legend somehow it's just a static tool that tells you, well, you can turn on or off some glyphs that you have hard-coded in with Python, right? It's just Python code. Sometimes, however, you want to enrich your plot with some extra information that has not been encoded. Let me say like this. Here you are showing just one single source of information, namely the overall evolution of a player. But possibly, in order to give more insights about that phenomena under investigation, you might want to tell your audience some extra information like the wages. If you know, sometimes the higher your overall, the higher the wage. Possibly you want to know the year of observation or the club in which he's playing. Okay, some basic information. So we want to add those information in the same plot. With Bokeh, that is pretty easy and pretty smooth, thanks to the Hoover tool. So the Hoover tool is an inspector that allows, as the name suggests, is an inspector inside a plot that allows you to add some extra information on a specific statistical observation. And in order to introduce this, I want also to tell you a very important concept in Bokeh. Bokeh is made of two main sub-modules, the plotting and the models. In the plotting, you find everything that is related to the graphical visualization. In the models, instead, you find all the utils that are necessary to improve the efficiency, performance, when you are creating a plot in Bokeh, and some backend tools that perform the dirty job for you when you are creating some plots. One of them is the column data source. Put in a nutshell, a column data source is nothing more than is the same of a Pandas data frame, but in Bokeh. So it's a way in which you store the data inside the Bokeh memory, and Bokeh is gonna perform more efficiently some operation if you ingest those data with a column data source instead of a Pandas data frame. So far, we have ingested a Pandas data frame. Now we are going to ingest those data as a column data source. And to do so, we basically import the column data source from the models, as simple as that. And for instance, I'm going to create those three data sets that we created before, the Vardy, Lukaku, and the Immobile. We are going to create them using basically the column data source. And to do so, we wrap inside the column data source function nothing more than the data frame that we wish to convert inside a CDS. Okay, we wrap everything. As simple as that, right? So I just wrap the data frame into a column data source. And if you try to inspect this object, you get a column data source and you are not able to see what's inside. So typically you can access to the attribute data, and you see that now you don't have anymore a Pandas data frame. You have the data are expressed as a Python dictionary. So that's why Bokeh performs much better with those data type, because in memory is more efficient. And again, you don't need to care about the dirty job. Everything has been done, is going to be done in the backend by Bokeh. So the column data source is just some, let me say, a sort of filter, data filtering, or better, a data util that allows Bokeh to perform more efficient. Okay, so we have transformed the data into column data source. Fine, pretty fine. And we, as I said, we want to create a plot that contains basically the overall evolution of each single player, but with some extra information. And those extra information are placed inside this list that I store into the variable tooltips. And this is a list of tuples where the first element is the label that we want to show inside the plot. And this het string is nothing more than the column that we have to look inside the data frame, namely the column data source, to enrich our plot. So to make life easier, I'm going to copy and paste the one that we produced before with the legend, and just copy and paste here. Okay, nothing strange. Again, it's the same thing, but now I want to add these tooltips inside the plot. And to do that, I'm gonna import the over tool, and I'm gonna use this function, and then basically I'm gonna add the over tool to the tools that we have seen before, the so-called gesture. And the gesture, remember, are nothing more than those tools, okay? Those are called in the backend gesture, but or also tools that are specific to Bokeh. So I'm gonna add an extra tool called the over tool by using the add tool function of the figure. And in particular, I'm gonna specify, as simple as that, the over tool by saying, well, I want the tool tips equal to the tool tips. The tool tips is nothing more, the tool tips describe the elements that I want to add on my plot as extra information. And then I can specify the mode in which those data are shown in the plot. And in particular, I specify, and this is my suggestion, but it's up to you, those information are shown by using a mouse click. So as soon as you point to a specific line or to a specific point in the graph, some information are going to be added. So also I want to use the circle glyph, which is nothing more than the same. It takes the same arguments as before, but it's gonna add some circle at a specific point in our line, so that, you know, it's the plot is gonna be more interpretable and more readable from a human point of view. That's it. So if you think about, we have just added this over tool thanks to the add tools method, and obviously we have to specify this list of tuples that describes the extra information we wish to have in our plot. Okay, so here it's okay, yeah, it's not necessary. If you think about why it's not necessary, simple, right? Because it's simple. The answer, I mean, the answer is the following. Before we were working with data frames, so the Pandas data frame function was a check that we were ingesting a data frame. But now we are using the column data sources, and column data sources doesn't know anything about Pandas data frame. They are the counterpart in Bokeh of those kind of data storage, right? So we don't need that. We just need to pass the column data sources inside the Bokeh plot, and everything should be ready somehow, but I cannot see them. Okay, yes, here is a problem because the source now is not the data frame but the data. because we are looping through the column data sources. Here we go. So we like this. So again, you have some interactivity with the legend, but look at this. This is the nice thing of Bokeh. We are adding some extra information to the plot so that you as a data scientist, you can go to your colleagues and to your stakeholders and share some results and giving them also the possibility to get insights that are not directly observable on that particular plot. So for instance, yeah, we are looking at the overall evolution of the player skill, but we don't know anything about the salary, the team in which he's playing, its age, and so on and so forth. Here with this simple tool, we are adding some information that tells us some information about the player, in particular the market value and the wage and the club in which he's playing. I love it. Believe me, I love it, and I use it as soon as I can, because it firstly will shock your audience when you show this interactivity with just a few lines of codes. This is the main motivation. And secondly, it enrich the data visualization. And for a data scientist, it's important that you get the raw data, you know the pipeline to transform the data, you know how to train a model if you are in machine learning. But at the end, once you have completed your pipeline, you have to share your knowledge, you have to share your results. And in this way, you give flexibility, but also interactivity in the plot, which is somehow undervalued as a skill for a data scientist. And Bokeh allows you as a data scientist to bring interactivity in a plot and to give a sort of value to your work. And I love it, I have to say. It's a very nice tool, pretty easy and pretty direct to implement. Okay, so we have a few minutes left. So we're gonna straight to the point. Here I produce, so we have focused on the evolution of the overall skill. Now I want to tell you how to plot categorical variables in Bokeh. It's pretty easy, obviously, but it's a different data. Before we had a time series, some data that were continuous over time. You have some observation, multiple observation over time. Now instead, you want to plot some categorical variable that have a distinct nature in their physical meaning. So I produce some methods for you. This method is gonna create some, is gonna extract the top countries with respect to the total players in the database for each single year. And for instance, you can say, well, I want to show those simple data that describe some counts with some glyph. So this is quite a standard. If you want to transform some counts into some plot, you use the bar plot. You can use the vertical bar or the horizontal bar, it's up to you. But the bottom line is the following. So I'm going to basically initialize a figure, and I'm going to use a p-bar that is gonna be based on the x-axis, the nationality from these top 10 countries data frame. Okay, so we got the y-axis in the v-bar is not y, but is called top. Is an argument, it's a different argument, and I call this count because I want those count to be shown as the height of our bars. And the source is nothing more than the top 10 countries. And I also specify the width of our bars. Okay, And an important aspect when you are dealing with such kind of glyphs, you have to add an extra argument inside the figure called X range. And in particular, the X range is gonna tell Bokeh which kind of element to plot in our X dimension. And for instance, I can take the top 10 countries, and in particular the nationality column. Well, that's pretty much because I can basically show the plot and add some aesthetic. For instance, I can say, well, I want each single bar to start from 0. So I want the Y range to start from 0. We just use we access to the attribute start from the Y range. If you are curious to know all these kind of details, in Cloud Academy, we have a few courses, but even the Bokeh documentation is pretty well written. So I strongly suggest either our course or to check the documentation on the fly if you need it for different reasons. And then we also want that the X grid doesn't have any specific attribute. So in particular, any color. So I'm gonna say the grid line color equal to none, so that the plot is gonna be more readable. So here we get this. We can do just the height. Okay, so we get a plot that it's nice because he is in Bokeh is gonna deal with for us the management of the x-axis thanks to this X range argument specified. And well, it's a pretty standard plot, right? So this is not my main goal. I just wanted to show you that it's possible to produce an histogram easily with Bokeh. But my suggestion and my focus in this last 5 minutes is the following. I want basically to answer to a simple question from a data visualization perspective. And the question is the following one. I have 3 countries, namely England, Spain, and Italy. And I want to see the evolution of the average salary for all those players in the last, say, 3 years. How can I do that? So basically, I want to see the average for each single country and for each single year. So I want to cluster the data with respect to nationality and year. And to do that, I can, again, use a V-bar because I'm going to create for each single year and for each single country a bar describing the average salary observed for the players in that particular country. And to do that, I have done the dirty job for you. So you find here a pivot table containing the wages, the mean wages by country and by year. And then I'm doing here some polishing and cleaning stuff. So at the end, you get something like this. You get a row described by the country, and the year described by obviously the year in which we observed those average salaries. Okay. Obviously, here I'm not normalizing with respect to the total number of players observed. You can think of it if you're curious, or you can write to me at the end of the webinar if you want to understand more about statistical analysis with respect to this dataset. There are a few things that we can do extra. So at the end of what I want to do is the following. I want to basically create a plot, a vertical bar plot in Bokeh that is clustered with respect to 2 dimensions, the nationality and the year. And to do so, we basically use another util called factor range in Bokeh that actually creates a grid for categorical variable for you in the backend. And in particular, I'm going to proceed as follows. So I'm going to create a list of tuples containing the country and the year. For country in basically countries that we define here in this list, and for year in the list years. Okay, it's a list comprehension, Python list comprehension based on two lists that is creating a list of tuples. If you don't get everything, don't worry, because at the end I will provide to you all the details. The most important thing is that you follow me on the steps on the way in which I'm trying to think in order to produce the plot. So I'm creating some objects, and then I also extract the counts, which basically is the sum that we can get from the data from 2019, data in 2020 and 21. Okay. And I also pass this empty list so that this empty object, so that I get the counts for each single tuple country. Okay. So I get this. I can create a source, a column data source, a CDS, and in particular is nothing more than a column data source, and we pass the data, the dictionary made of our X and the counts equal to the counts that we just defined. So we created the column data source, and we want now to create a bar plot in a similar spirit as the one that we did here above. So I'm just gonna copy and paste, and in particular we are gonna take into account first the X range is not gonna be top 10 countries nationality anymore, but we call the factor range function, and we pass nothing more than the list of tuples of country years. If you think about country and years in our data set are strings, and therefore are categorical variables, and this factor range is going to take for us into account the fact that they are categorical variables, and it is going to create a grid that is going to be our x-axis from categorical variables. It's basically the same thing that we did with before with just a single categorical variable, nationality, but now we have two clusters, nationality and year, that are two strings, and we want to cluster them. So we use the factor range, the plot height, let's put 350 for simplicity, and then we basically create, it's fine, for the moment it's fine. We create the v-bar by passing x, we pass the counts, we don't need, we basically pass a CDS here. And that's pretty much, because now we specify the range start equal to 0, the green line color none, and we can also specify as an X range the range padding, which is gonna take into account the distance between the two clusters that we are defining now, and we set this as 0.1. And we also specify another extra argument that is going to take into account the label orientation, and it should be x-axis, right? It should be x-axis, major label, something like this, major label orientation, and this is equal to 1.0, for instance. Let me say 1. So let's try to plot this here we have this. It's fine. We can basically, what can we do now? We can specify the width here as 0.8, so that they are not going to be merged together. Here we go. It's much better. So the idea is the following. So we have translated a complex question from a data perspective. We cluster those questions into, we merge those two questions inside a single plot, clustered by two dimensions, the nationality and the year. And you see that the plot is more readable. You can understand what's going on with respect to each single country, with respect to each single year. How can we, and the process was pretty simple, because once we did this dirty job, the process was just to add some specific on the attributes of each specific x-axis or y-axis. And that was pretty much the end. At the end was pretty much the dirty job. So for me, I'm done. Let's see whether you have a few questions. Okay, there are a few questions. So one is more general, whether so why should I use Bokeh instead of other libraries to create dashboards? Well, as I said, there are many motivation to use those kind of libraries. It depends on your goals. But I have to say that Bokeh allows you to bring flexibility and interactivity inside the plot. So if you want to master data visualization with Python, I strongly suggest to start with the basic, namely with the standard libraries like Matplotlib, because at the end everything is based on Matplotlib. So if you understand it, you will be able to understand and develop new features with other libraries. But you know, it depends on the time that you have. Possibly, if you use a tool like Bokeh, you have everything ready. And also Bokeh is well integrated with new tools for data visualizations, such as Streamlit, and therefore it has been used as a benchmark for interactive data visualization nowadays, especially if developed with Python. Then I have there are other questions. So in particular related to the possibility to add extra feature here in the plot, in particular the title. And the title, we have seen it, so it's pretty easy, because you just need to specify inside the figure the title arguments here, and you pass some string here, and then you see here the result. But you can also deactivate, and this is nice question, the toolbar. You can specify toolbar equal to none and the tools equal to empty list, so that at the end you will not be shown with those tools if you are not interested. So the way in which you do is the following one: toolbar location equal to none and tools empty. Okay, for me that's it.
All right, thank you, Andrea, and thank you everybody for joining us. Before we part ways, just a couple of reminders. As mentioned in the beginning of this session, this webinar was recorded and you will receive it via email. In that email, you will also find some useful resources such as courses, previous webinars around these topics. And also at the bottom, you will find the registration page for the next session that Andrea will be leading, which is scheduled for July 29th and will focus around Fast API. We've added some links to the webinars that Andrea has done, but in any case, if you want to browse also other topics other than the data science, you can head to our website on cloudacademy.com/webinars, and you will find all of the sessions that we've done in the past. Last but not least, please fill out the end of webinar survey, as your feedback is super important to us. We want to know what you liked about this session, what we can improve, and we just like to hear what you thought about our this session in particular and what you'd like to see in the future. Again, thank you so much to everybody that joined us today, and thank you, Andrea. Looking forward to working together again soon. Bye, everybody.